I'm with Pacific Northwest National Laboratory, and we have a great meeting here today. This meeting is being put on by RemPlex, which is the Center for Remediation of Complex Sites, which was established at PNNL a couple of years ago. And I'm one of the co-directors of RemPlex. I'm here with a number of colleagues. Nick Chafuku is another co-director of RemPlex. We're thrilled that we're hosting this meeting today. RemPlex was established to promote knowledge transfer and networking and collaboration, all in the realm of environmental remediation. And an important goal for RemPlex is to promote professional development. And we do that through a variety of events throughout the year, seminars, and we're hosting a meeting this fall, next fall, the Summit of Environmental Remediation. And these activities bring people together to share their knowledge and talk about the challenges and issues associated with environmental remediation. And we support professional development for those of us who've been working in the field for some time, as well as we hope for people that are just entering this field. And so that's the purpose of today's seminar. I'm going to turn this over to Chris Johnson. He's another member of the RemPlex team, and he coordinated this webinar today. And our goal is to share a lot of information with people who may be interested in internships in the field of environmental science leading into remediation work. So Chris, thank you for organizing it, and I'll turn it over to you.
Great, thank you, Karen. And welcome everybody. We're really excited to have you here today. And we've got a good lineup. I'm going to start out talking about what the national laboratories are and environmental management, touching in on RemPlex. And then we have a good lineup of staff and interns to talk about what they do and what their experiences are, kind of give you some different vignettes of that background. Then I'll talk about internship opportunities, different programs, a little bit about tips and preparing, what mentors look for. And then we'll finish up with a Q&A opportunity. So the Department of Energy, National Laboratories, these grew out of the Manhattan Project, or the development of the first atomic bomb. And they really are a resource for performing critical research to solve the nation's most challenging problems in several different areas, mission areas, the scientific discovery, energy and environment, national security. And it's the work spans from basic research, fundamental science, to development and actual demonstration of technologies. The national laboratories are really the most comprehensive research and development network of its kind. There's 17 laboratories, and each laboratory has some unique scientific tools and facilities and capabilities. And we'll touch on that in just a second here. And the national laboratory system, across the national labs, they're routinely recognized for their innovative research and technology transfer, winning multiple R&D 100 awards every year, and the Federal Laboratory Consortium Tech Transfer Awards, routinely being recognized for those. So there's a couple of links here for some more information at the DOE website on the national laboratories. And there's actually a nice little 17 labs and 17 minutes video podcast that goes through each of the labs and kind of highlights what they're about. So here's a map just to show you where the labs are located and kind of give you an idea of their focus areas. So they're spread across the United States. Again, there's 17 national laboratories. Some of these are doing Office of Science work. Some of them do energy and environment work, and some do national security. And we can kind of give you a little different view here, the same information, just to show you where labs fit in terms of science and technology. Again, there's the multi-purpose science labs, there's multi-purpose security labs, there's one lab at Savannah River that focuses on environmental work, several labs do energy technologies, and then there's some single program labs like Jefferson Lab, Fermi Lab, etc. So covers quite a range of research and development. And here, this is not all the mission areas, but this gives you a pretty broad idea of what the national labs do. It's everything from earth science and environmental management, which is our focus here today, But biological science, chemical and materials sciences, the advanced computing, data science, carbon management, all those things really touch on what we're doing in terms of environmental restoration work. In addition, there's a variety of energy, renewable energy, energy efficiency, infrastructure, energy security, and then things like nuclear non-proliferation, nuclear particle physics. So wide breadth of things that go on at the national laboratories in terms of research and development. So what we're talking mainly about today is environmental related work. And this is primarily through the DOE Office of Environmental Management. This was an office created in 1989, and it's really to address the legacy of the Cold War efforts. So as of 2020, environmental management has 16 sites in 11 states, which is down dramatically since they started in 1989. And I'm showing here a picture of a tool called Track. And the URLs there, track.pnnl.gov. This is actually a good place to go to get some information on the Office of Environmental Management. If you look at the related links, you'll see these different links up here that talk about the department, EM by the numbers, looking at the cleanup sites, etc. And this tool, as you browse through, you can look at the different sites, and there's videos that give an overview of each site. So these are the cleanup sites. This differs from the national laboratories. National labs do research. Cleanup sites are where there was production activities or research activities, and we now need to do some cleanup. You can also go to the this link here, the energy.gov EM cleanup sites, that shows the sites as well and describes them in a bit more detail. So these are the challenge areas where we need to clean up. Again, the EM has made a lot of progress since inception. They reduced the number of sites from 107 to 31. And okay, 107 sites in 31 states to 16 sites in 11 states. You see on the little bar charts here how we've improved cleanup and clean up different sites. Down at the bottom here shows Rocky Flats as an example. This was a site that had a lot of production facilities, and it's been entirely cleaned up and restored, and is a good success story. So what's left are really the most challenging cleanup issues at these 16 16 sites. And the national laboratories, again, they play a key role in solving the challenges in the environmental cleanup. So a related office is the Office of Legacy Management. So once sites that EM oversees are cleaned up, they're transferred to legacy management for long-term stewardship. So legacy management does some remediation, some environmental restoration. It's more about long-term monitoring and long-term stewardship. And they actually have a number of other sites as well, some former uranium processing sites. There's formerly utilized sites under the FUSRAP program. There's some deactivation and decommissioning and various other sites. So there's other related sites under Department of Energy that are for being managed in terms of long-term stewardship. RemPlex, Karen talked a little bit about RemPlex at the start here. Again, it's really intended as a forum for collaborative work to look at the challenges of cleanup and environmental restoration. Here are the big problems, and how can we work together? How can we come up with new technologies to solve these problems? Because there are some significant challenges across EM and elsewhere, even outside of the DOE complex. So RemPlex, again, it's this forum to discuss challenges, looking for innovative solutions. So we're talking about things like lessons learned. What have we done at Hanford that might apply at Savannah River or something like that? Really trying to better understand what are the remediation needs across the globe, and look for ways to collaborate and solve those issues. You'll see in the picture here, we're really going from basic science through actual deployment of technologies. So trying to understand the fundamental issues and characteristics and features to deploy technologies that solve the problems. And as Karen mentioned, we do a global summit that brings people together in a meeting. The next one's this fall, and we do a variety of seminars to talk about topics of interest to the complex sites. So in terms of what we're talking about today, workforce development is actually really important for Department of Energy and the national labs. We need people to come in and help us take on these challenges and do the research and solve problems. So we're talking about student internships today, and in the context of environmental cleanup. And I want to highlight that this is not just about hiring environmental science students or environmental engineers. This is really a multidisciplinary effort. It's a team effort when we're solving these problems. So it takes engineers, but material scientists, geologists, physics students, chemistry, biology, and even computer science and data science. These are all, this wide breadth of fields are all really important to pull together and solve the problems that we're facing here. So at this point, I'm going to turn this over to our speakers, and we're going to go through a series of speakers here. And I'm going to start out with a programmatic view. So John Moon is from DOE EM headquarters, and he's the MSIP director. And I'll turn it over to him to say a few words here.
Thank you, Chris. Hi, my name is John Moon, and I manage the Federal Minority Serving Institute Partnership Program at the Department of Energy Environmental Management Office. I wanted to also welcome you to RemPlex seminar on the internship in environmental science. Next slide, please. Next slide. Okay. As stated in the invite that you all received, there is much need for researchers and scientists as a part of multidisciplinary diverse team working to solve some complex environmental issues. We picked all the easy reaching fruits previously. I mean, we went down from 107 sites to 16 sites. We went from 31 states to 11 states. That's a lot of cleanup, and now we have some more difficult, more challenging difficulties. So DOE is engaged with universities and colleges and laboratories, providing opportunities to inform students of real challenges in the EM mission and positions student to for the future workforce. And my program was designed to help address EM's future workforce needs by partnering with academic, government, labs, DOE contractor organization to mentor future scientists and engineers who will address environmental cleanup challenges. And Congress believes in our program so much that they have increased from $6 million in 2021 to $56 million in 2022 and 2023 as well. Next slide, please. We have provided this year $30 million in grants to university and colleges so that they can provide scholarships and internships and get you guys ready for challenges that's ahead of you. In addition, this year we have increased competitive research awards from $10 million, and it reaches over 24 institutions so that staff and students like yourself can be involved in environmental cleanup challenges. We have created graduate and postdoctoral programs for you to look forward to when you want to achieve higher educational goals. But specifically, next slide, please. For internships, we have doubled down on availability. We have increased number from 25 to 50 internships this year. And also for internships, specifically for environmental field station, we have increased from 20 to 40 students. This number of internships are just headquarter funds. There are so many more from other DOE offices, such as science and legacy management, from DOE field sites and national laboratories. And personally, For environmental management, I feel that there's no better time to apply for internships and graduate programs than today. So I want to thank you, Chris, and Karen, for allowing me to speak today. I think this is a good place to stop. I'll send it back to you, Chris.
Great, thank you. So that gives you a little introduction in terms of from the EM headquarters perspective and the MSIP program. And now we're going to go on to our staff and have staff speak. So we'll start out with Sarah Saslow.
Hey everyone, I'm Sarah Saslow. I am a chemist here at Pacific Northwest National Laboratory, and my background is in geochemistry, but since coming to the lab 7 years ago, I've been able to build upon that expertise and include aspects of material science, materials characterization, and apply that to really interesting research challenges. Right now, my current project portfolio really revolves around how we can develop cement materials for the treatment of nuclear waste stored out at the Hanford site, as well as exploring how different technologies can be used to treat subsurface contamination. And that kind of combines both, an understanding of fate and transport of these contaminants within our subsurface, and then how we actually remove them and treat them so they're no longer a threat to our health and to the environment. Next slide, please. So Chris asked us to kind of highlight or showcase a project and what our day-to-day approach to solving research challenges would be like. And so here is an example of how we approach our cement work. So the overarching objective for this research program is to design these cementitious-based materials for storing nuclear waste for up to 10,000 years. So we need to reduce the risk of these contaminants for that period of time, which is just a mind-boggling number if you really think about it. But we take it one step at a time, starting with our formulation. So what we actually combine to make the cement is going to make a huge impact on the outcome or the properties. And often we'll have operations, how the facility is going to make the cement, and regulations that require certain properties to be within the materials. And so we can fine tune the dry ingredients and even the water content in order to produce those properties. Once we have a cement that we think is a really good candidate, we'll undergo a whole bunch of testing. We often use standardized procedures in order to do this, to demonstrate that we are in fact able to meet the requirements of the project. And then we also will sometimes look into the mechanisms for why things are working. So not just showing that they will work, but the why. And so we can use really interesting and fun techniques to track like how a contaminant is going to migrate through a cement. How does its chemistry change based on the chemistry of the cement itself? And all of that can lead us to reiterating how we look at the formulation and making improvements. And then ultimately, once we have a nice cement candidate waste form, then we'll look towards engineering and scale up. So reproducing what we can do at the laboratory, like in a 1 liter volume at scale, so much larger. Next slide, please. And yeah, just real quick, I wanted to highlight the fact that I did not have a linear path to get me to PNNL. I actually started in the space department, doing an internship at Johns Hopkins Applied Physics Lab, and then bounced around, did a bunch of interns and different work work experiences throughout my undergrad that got me into grad school, and then ultimately landed me here at PNNL, where I work at cement, which is very different than the meteorites I was studying at Johns Hopkins Applied Physics Lab. Yeah, so I'll leave it at that. Happy to answer questions, and on to the next person. I think it's Fred, right?
That's correct. Yes.
Okay.
So Fred Day Lewis is another staff member. We'll talk about some of the work he does. You there, Fred?
Sorry about that. Can you hear me now?
Yep. Good.
All right. I'm going to go in reverse order to what Sarah just did, and instead talk about how I got to where I am at PNNL, and then talk about my research and where interns have fit into my work in the past, including this past summer. So I took also a circuitous route to get to where I am, having started as an English major in college and having very little idea what I wanted to do for a couple of years before I found my way into hydrology, which for me was a nice blend of engineering and physics and math and chemistry, and allowed me to pursue a lot of different interests, working outside, being in the environment, and trying to clean up contaminated sites, like Chris introduced earlier. And I've been doing that ever since. After doing a PhD at Stanford in hydrogeology and getting into geophysics, I've been doing geophysics ever since, and I'm now a chief geophysicist and lab fellow here at PNNL. So my current research is all focused on groundwater remediation and understanding processes in the subsurface using geophysical methods. These methods allow us to see into the earth, much like medical imaging allows medical professionals to see into the human body and understand different processes and problems. We can use methods like seismic, radar, electromagnetics, electrical resistivity, and other physical methods to see into the earth. And we can measure these properties over time for time-lapse monitoring to understand how things are changing, how sites are being cleaned up, or where injections of amendments are affecting subsurface conditions. I came to the lab about a year and a half ago after 18 years at the US Geological Survey, also working on some of these problems, and continue to apply these problems to the Department of Energy sites that Chris mentioned earlier, as well as in projects for EPA, the Electric Power Research Institute, Department of Defense, and other organizations. This past summer, I was very happy to be able to take advantage of the internship programs that we have through DOE, and took on an MSIP intern for the summer who contributed to 2 different publications, one of which was writing up computer codes in Python to help understand where contaminants were coming into wells based on different measurements that we can take of flow in the well, and understanding the exchange between the well and the aquifer around it. Now, as Chris mentioned, this is an all hands on deck kind of problem where we're not looking just for geologists or just for engineers. There's room here for students coming from backgrounds in physics, computer science, data science, you name it. This is an all hands on deck kind of challenge that we face. And that's it. Thanks very much for the time.
Thanks, Fred. And next we'll have staff member Amaret Bunn talk about her experiences and work.
Next slide, please. Okay. Hello, I'm Amaret Bunn. I'm a senior environmental engineer. I've been at PNNL for about 25 years. And I took a very interesting way of getting here that I'll talk about more in a moment. My big interests are about natural resources, analyses, and management of those resources. And when I talk about natural resources, I'm not just talking about outside an aquatic or terrestrial environment. I'm also talking about how we use those resources as well. And so I particularly appreciate a very comprehensive way of looking at our resources, our environment, and how people interact with that. Lately, I've been able to take one of my specific interests with radiation detection and mount that onto a unmanned aerial vehicle and get a chance to work with people who can fly my sensors around for me. And we can start evaluating those possibilities in the future to use automation. So in my interests areas of human health and ecological risk assessments, I very much have had a lot of great opportunities to work with teachers, to work with students of all sorts of different backgrounds. And it's been part of our processes to conduct these assessments in a manner in which we can continue to look at environmental remediation, look at our opportunities, whether it's at the Hanford site where we're dealing with radionuclides and heavy metals, and to a lesser extent, organic compounds. We're actually working on a oil spill and how to clean that up. What are the ways in which we can actually prepare in our work to mitigate even having a spill in the first place? So that's often involved experimental design and decision analysis. All decisions really come back down to what our regulations are. So in that case, I'm even working with people who are lawyers, as well as environmental scientists, data analysts, computer specialists as well. I've really gotten involved over the years with combining all my interests in human health and ecological assessments with incident response and biological agent awareness. So I'm actually talking to you from Rabat, Morocco. Yes, the World Cup game is going on right now. It seems to be quiet, so maybe it's halftime. And so next slide, please. This interest that I have with human health and the environment really comes up with, I grew up in Virginia and I got a chance to work at the Smithsonian's Natural History Museum working in crustaceans. I went on to Virginia Tech, and then I wound up being really interested in applied areas. And at that point, I went into civil engineering. This allowed me to go to the University of New Hampshire for my master's and PhD. And I actually overlapped with Fred for a few years. And while I was there, I got a chance to go study at the British Natural History Museum. So I got a real love for museums too. But when I started working with the Department of Energy, I got a chance to work with the whole periodic table and all the molecules and compounds interacting. So I look forward to an opportunity to perhaps work with some of you all in the future. Thank you.
Great, thank you. So that gives you, so there's 3 staff members that kind of describe some of the things they've done and how the path they've taken. And hopefully that gives you kind of a sense of the sort of things we do at the National Laboratory. And now we're going to move to some former interns and have them talk about some of their work and their experiences and their thoughts. And we'll start with the high school program intern, Jordan Perkins, and I'll let her talk about her experiences.
Thank you, Chris. Hello, everyone. I'm Jordan. So I am currently a senior at Richland High School, and I am planning on studying environmental chemistry or toxicology at Hoping Western Washington University. Haven't gotten that completely tacked down yet. But a little bit about what I did before I did my internship. So I was an AP capstone student, which was a 2-year program at my school. And it basically talked about research. And so for 2 years, I did research projects. And at the very end, I developed a research paper based off of an experiment that I did. So that was pretty interesting. And a fun fact about me is that 2 years ago, I was our Tri-Cities Miss Juneteenth first princess. So that's a little fun fact about me. Next slide. So for the summer, I worked under Chris Johnson, actually, and the main basis of my internship was to develop a function to identify data gaps and overlaps in our Hypatia software. So that basically was sensor data that we recorded based off of the under the aquifer, and so that's basically what we were doing. But I first developed the prototype in Excel because I actually didn't know how to code before. And that was a huge jump that I had to do, especially as a high schooler. And later I moved on to JavaScript. And it was a super challenging project that I was presented. And it had a lot of different things that I had to learn, not to mention coding, but also networking and talking to different professionals. And it was an amazing experience that I was able to be presented with. And after I developed the software that I was super proud of, It's also supposed to be projected to be implemented into Hypatia. So that's something that I'm super proud of that I was able to develop. And that was basically with the intention to help with statistics and machine learning. I think there's a next slide. Awesome. So as a high schooler, it was definitely difficult to have any past experience because all I've been in is in a classroom. So I'm a little unique in that way. But what I did for any high schooler out there is have a really good resume and a really good letter of recommendation. That is something that anyone can do. And that was super helpful for me. And also having challenging classes was something that I was able to accomplish. At PNNL, I learned a lot of amazing things, not to mention the hard skills, but the networking, the online networking that I was able to do and the connections I was able to make was worth its weight in gold. And I was super happy about that. And take advantage of asking questions when you're there. Being a high schooler, you don't know a lot. And it's a little intimidating to see people that are so far into their educational career and you're at the very start of it. And it can be a little daunting to see all these experts in their field, but having the confidence to ask questions is a skill I had to develop. And it was difficult at first, but it was a skill that I'm very happy I was able to acquire. Something interesting that I learned at PNNL is that the environment is competitive, but it's also super supportive. Seeing all these experts, sometimes you don't know if you're going to be able to flourish in a way that you hope. But PNNL definitely has the environment to help you grow and support you throughout your educational career. And it helped me a lot. And I'm super grateful for that. And going from high school to the workplace was definitely super amazing, but it challenged me to think outside the box, which is something that the classroom doesn't provide you with. And usually the classroom will say there is one problem and one solution. And going to PNNL helped me realize that that's not true. And being able to be presented with a problem that had multiple solutions or the combination of a few solutions was something that was super eye-opening. And as someone that's planning on going into the environmental sciences, being exposed to these different topics was super amazing, and being able to be shown how wide our world actually is and the things that are just outside of my fingertips. And it was super amazing, and I'm super grateful for this experience.
Great. Thank you, Jordan. So now we'll move from a high school intern to an college undergrad, and that's Arabella Chamberlain. Go ahead.
All right. Hi there. My name is Arabella Chamberlain, and I recently participated in the summer 2022 SULI program. So that's the Science Undergraduate Laboratory Internship. And I had graduated just this May with my BA in Physics and Computer Science from Coe College in Iowa. Some of my previous research experience included analyzing NASA MARSIS data. So I used Excel for the data analysis of local electron density profiles, and this was some work I did in undergrad. I also improved atmospheric correction and airborne radiance retrievals, and this allowed me to the opportunity to analyze data in ENVI, SNAP, and Acolyte, which are some GIS or Geographic Information System softwares. And I also applied several standard and novel atmospheric correction techniques. And now I am currently continuing my education in the Atmospheric and Oceanic Sciences program as a first-year PhD student at the University of Colorado Boulder. Next slide, please. So my work over this past summer focused on Hanford site monitoring. And so the Hanford site has over 800 waste sites, as we've kind of talked a little bit about before, which can be kind of hard to monitor on that scale. And so that Hanford waste site was contaminated during nuclear development in the 1940s. And the waste has now reached below surface-based removal methods and poses a risk to the groundwater system. So some of the reasons that this was really important was because the risks of groundwater contamination include degraded drinking water quality, high cost of cleanup, and the disruption and destruction of ecosystems, and so many more implications. So my goal over the summer was to monitor subsurface fluid flux through the barrier, and flux is the distance the water has moved downward in the vadose zone over time. Also, the prototype Hanford barrier was constructed in 1994 to mitigate risks of groundwater contamination. Next slide. So some of the goals I had then this summer was to apply neural networks on the smaller scale of the prototype Hanford barrier to use on the larger scale of the Hanford site as a whole. And so some of this work then allowed me to strengthen my skills in Python and JupyterLab, TensorFlow and Keras, and Excel. So some machine learning skills, some coding skills, things like that. It was a really great opportunity. And some of the things I found was that subsurface moisture data is necessary to predict the flux with neural networks, and that neural networks can outperform linear regression models in predictions of subsurface flux. But neural networks can be difficult to construct, but they may be less time consuming and more efficient than current techniques. And so a lot of this work over the summer too, it really helped me to not just develop those hard skills of like computer science and things like that, but I also developed scientific writing and communication skills, and I gained an encouraging mentor. And I also got to experience the day-to-day life of a researcher in a national lab. Next slide. So from my experience as a DOE intern, what did I do to prepare? Well, one thing that was really helpful was developing skills in computer science. So learn a programming language if you can. Python is a really great place to start. It definitely helps to have those skills coming in, but as Jordan mentioned, you don't always have to have those computer science skills coming in too. Like having skills in Excel can be really helpful too. Read up on current research I was interested in. So if you're looking to do a different project, things like that, or you're getting interested, try to like look up some papers maybe about the project you want to apply to. That helps give you a feel for the research. And some things that might have been useful to do would be to maybe take a statistics course. Lots of analysis requires a basic understanding of statistics. Take a class online or learn if you can. However, I had personally never taken any statistics, so it was something I picked up on the fly from my research as well. So that was really helpful. And then also take the initiative. Always be ready to take on a new opportunity. You never know what will come out of it. My mentor constantly encouraged me to just like take out new opportunities, try different things, approach problems from different perspectives. And that really, really was a great skill to have. And my overall thoughts was that I had an amazing time and grew so much as an independent researcher during my time in the Sully program. My mentor challenged me daily and helped me become a stronger scientist who thinks critically and asks questions, like Jordan mentioned, and helped me develop connections to other scientists and opportunities. Creating a final report and presentation was also great preparation for the kind of work I would face in my graduate studies. Working as a DOE intern is a great springboard to get experience with research in a safe and supportive environment. Thank you so much, and I'll pass it on to the next person.
Great, thank you, Arabella. And our third student is going to speak. We'll move up to graduate level. So Mariah Doman.
Hi, everyone. I just want to say that Jordan and Arabella, you guys did great, and that Jordan mentioned that it was a little daunting being a high school student, but I find that very inspiring and impressive that you had that opportunity to work at PNNL over the summer, because I definitely didn't know anything about PNNL when I was in high school, and I didn't know what I even wanted to do. So that's really impressive and inspiring. But I'm a graduate student currently. My work is funded by the DOE FIU Science and Technology Workforce Development Program. We get a lot of funds from MSEP, but I had the chance to do an internship in the summer of 2022, and I was able to work under the mentorship of a few different people, including Nick Kafoku, who is here today. But outside of the internship, I'm a DOE fellow working in the soil and groundwater laboratory, and I'm a PhD candidate in chemistry. So a little bit of background on some of the work that I've done includes commingled contaminant fate and transport in the subsurface, and also host guest interaction for the development of an economical rapid assay for field detection of PFAS in water. And my career interests include geochemistry and remediation technologies for radionuclides and other contaminants of concern. And the image on the bottom is one of the pictures of me working in the lab this summer. Next slide, please. So the project that I was able to work on in the summer focused on the sorption and desorption of chromium in Hanford sediments. So that means how chromium sticks and then gets released from the sediment. And that was to determine if the chromium that remains in the subsurface, which really was placed there, chromium was used as a corrosion inhibitor in the tanks that hold the waste at the site, but was unfortunately got into the subsurface during that time. But we want to determine if that chromium that remains undergoes natural attenuation processes. So processes that can slow that movement of chromium through the subsurface. So the approach was to use sediment characterization, batch absorption studies, and column studies. I have a few pictures of the column stuff that I did this summer. The top picture shows the column itself along with the pumps that we used and the fraction collector. The bottom left two images show the colorimetric method we use to determine the concentration of chromium during this experiment. And then the two pictures on the right show the probe and meter that we use to determine the concentration of bromide, which we used as a sort of model of how water would move through this column. Next slide, please. So the outcome and implications, really the image shows the two different breakthrough curves, as we say, of chromate and bromide. And you can see that they're very close to each other. And that means that chromate essentially has very minimal retardation through the subsurface. So it had a very low retardation coefficient. And this allowed us to determine the KD value of chromate, which is really just the measure of the concentration of chromium that's stuck to the sediment versus the concentration of chromium that's in the aqueous phase. So we determined that that was a very low value as well. And we found that that value was much less than from batch experiments. And this is possibly due to an increase in accessible clay adsorption sites from stirring and abrasion, and also from a longer residence time in the batch studies, which was 14 days versus 1.7 hours in the column study. So overall, the results indicated that chromium will be mobile under site conditions, and this should be considered when developing possible passive remediation strategies, which includes monitored natural attenuation. Next slide, please. So I learned quite a few things when I was at PNNL this summer, especially the new skill set in being able to establish and run a column experiment. There's a lot that goes into these experiments, and I was very lucky to be under the guidance of Jim Sikoti, especially in the lab, and just learning that technique physically was really important and useful for me. Something that inspired me was the ability to go on the B reactor tour. It was very inspiring and brought into perspective the work we do and the overall mission of DOE-EM. The top two images show figures of me at the site. The middle image is of me in the control room chair of the B reactor, which is really cool. I also really enjoyed networking with and learning from scientists in the Energy and Environment Directorate and other PNNL staff. I enjoyed going on tours of different lab spaces and also meeting and learning from other PNNL interns. They did a really great job of setting up different events that we could go to network with fellow interns. And that included a luncheon that we had outside. It was a beautiful summer there that I really enjoyed. Something that is good for preparation is reading mentors' published work, which I believe Arabella mentioned in her presentation. It just gives a good summary of what to expect to work on, and also can give you sort of a background in what they're working with. Thank you.
Great, thank you, Mariah. So now we have two more speakers who are going to talk about their path from actually being an intern to full-time staff member. And we'll start with Jackie Wells.
Hello, everyone. As Chris said, I'm Jackie Wells. I'm an Earth Scientist 1 at PNNL. Most of my research focus is about soil and groundwater remediation and monitoring. And more recently, I've actually expanded into looking at glass durability when it's been deposited out in the environment. I've done a lot of different projects ranging from biogeochemistry, environmental microbiology, and now into glass material science. I've worked in labs, I've done field work, I've done radiological work, and I've run a variety of analytical instrumentation as well. Next slide, please. So my path started where a lot of you are. I was an undergrad, I joined a club, and they were doing some lab work looking at some biocement, which is essentially tricking soil bacteria into producing calcium carbonate, and it literally cements the soil particles together. I really enjoyed all the lab work, so I wanted some more experience, and that's how I came upon the SULI summer program. And that first summer, I got to work on the bioremediation potential of a particular microbe in reducing the iodate and nitrate plumes that are out on the Hanford site. Then I had so much fun that first summer, I came back a second summer and got to expand my project to also include a competitive ion, iron, and then work with 3 more microbes to test those different studies. Then after I graduated, I came back to PNNL as a full-time intern, where I got to look at evaluating the effects of a cyanide plume that is out on the Hanford site and its impacts on the natural microbes out in the groundwater. And then I also got to do my first dose of field work, which I grew to really enjoy. We actually installed a whole bunch of aquifer tubes along a transect of the Columbia River so that we can monitor different water quality parameters more or less continuously for about 2 years. Next slide, please. So I was an intern for about 6 months, and then I applied to become a post-bachelor's research associate, and that's a 2-year position. During that time, I got to work on a project that was evaluating ancient glass from a pre-Viking hill fort in Sweden, and we were evaluating what kind of alteration the glass and soil had undergone while it was out in the natural environment. One spring, I got to tag adult salmon coming up the Snake River to spawn. And I got to continue doing more field work by going to a bunch of different sites in the Pacific Northwest, taking soil and water samples so we could build a database of different water quality parameters in watersheds all over the world. So all of this experience was just amazing. And I realized that I really loved environmental research, and I realized to continue moving ahead in that career, I needed an advanced degree. And so that's how I wound up at Oregon State University to do a master's degree in environmental engineering, where I focused on stormwater remediation. So I did some flume studies, and then I also helped build a full-scale bioswale just off of campus to help remediate stormwater runoff from an industrial site. So after I defended my master's thesis, I came back to PNNL and was hired on as a staff scientist, where I have continued working on that ancient glass project, where we are now applying what we learned before to how do we tackle the implications of nuclear waste glass disposal. So that's been really cool. And then I've also been helping evaluate some pump and treat resins. So they have got columns out on the 200 West area of the site, and they're pumping groundwater, and they're actually removing contaminants from the groundwater with these resins. So we're doing some chemistry to figure out exactly what's working and if there's a way to improve it. So I've been actually able to do some radiological work, which has been very exciting. Next slide, please. So I know that was a lot. So the main takeaways that I want to give you guys is that first summer internship really built the foundation of technical skills that I still use to this day, every day. Lab techniques, how to plan a project and see it all the way through, the data analysis, and then writing about it so you can actually tell the community what you found. It opened opportunities from just being a summer intern to being a 2-year position as an RA to being back as a staff. And I had no idea that the whole environmental cleanup field really existed until I did my first SULI internship, and I just fell in love with it. And it's just, carried me so far, and it's been rewarding and amazing all around. And all of this experience that I had was instrumental to me getting into graduate school. It showed that I could take a project from start to finish, complete it successfully, and then publish my results, which a lot of grad school programs do look for. And last but certainly not least, this whole experience connected me to so many highly respected researchers in their fields. And I was lucky enough to have a couple of them be mentors for me. And they put in a lot of time and investment in helping me find career opportunities and sending me to conferences where I could present posters and connect with people even outside the PNNL network. So if I could go back, and do it all again, I 100% would, and I would highly recommend all of you guys to consider applying for us for a summer program as well. And thank you, and I'll pass it on to the next speaker.
Great, thanks, Jackie. So our last speaker is Emily Fabricator, and you can hear her story.
Hi, everyone. I had a very different experience than Jackie, but I think that's, good to get an all-around experience, and you can see that there's different ways to get to where you want to be. So I'm an environmental scientist at Savannah River National Laboratory. I have a bachelor's in biology and a master's in environmental biology. And between 2011 and 2016, when I graduated with my bachelor's and started my master's, I did absolutely no science work. I had no clue what I wanted to do. So I decided to go back and get an advanced degree so I could try to start my career. So there were a few paths that I could take to graduate. I could do a thesis and an independent project, take a class, but I realized with absolutely no work experience that I needed to do an internship to meet people, get that work experience. And even though it was scary and I'm shy and it was very daunting, I said, it's in my best interest to do that. So I really need to do that. So I applied to be an intern at headquarters, and I started there in summer of 2019 through the DOE Scholars Program. Next slide, please. So headquarters is a little different than working at a lab. For an internship, there's no field work or real lab work to do. So my short presentation is going to be a little different than everyone else's. So with my internship in the Office of Subsurface Closure, my main project was to collect pump and treat metrics at different DOE EM sites. And it seems like pump and treat is a hot topic for a lot of us as interns and graduate students. So that's kind of tracks with everyone else, which is kind of interesting. So my project included collecting installation costs, monthly operational costs, contaminants treated, the age of the system, projected closure date, things like that. And I compiled that and then presented it to senior level management. I also wrote a waste management paper on it. So those were two really great outcomes from just one single project. I was also able to visit Savannah River site with my fellow summer interns to get an experience of what it's like at a site. And that was a great couple days to kind of see what the labs are like. I really enjoyed that. So I was fortunate enough to be able to stay on as a long-term intern. My original internship was 10 weeks and I didn't want to leave, and they were gracious enough to let me stay. So I stayed for about 13 months. So I did similar projects during the extension part of my internship, where I collected complex-wide data for integration into larger projects to solve complex-wide issues. So that's pretty much what I did in my internship and also now. So I was able to collect monitoring well statistics and information, PFAS inventories, coal ash inventories throughout the complex, and also data and document collection for integration into TRAC, which Chris mentioned earlier. And that was really great because I was able to make a lot of relationships with people outside headquarters and outside the people I knew in general. And I've been able to continue those working relationships with a lot of people at the sites and other labs, which has made my job at Savannah River a lot easier because I've been able to keep those relationships going. Next slide, please. So I was able to take the tools that I acquired from my internship and my master's program, and I've been able to expand them into a variety of programs at my full-time employment at Savannah River. So a lot of my work is through the Technology Development Office and the Lab Policy Office. And those are really great offices to be interacting with because they focus on emergent work and high priority important issues. So I work on those high priority technical needs through applied science, which makes my job very exciting and fulfilling. I couldn't really see myself doing one project for 30 years and then retire. So I get to do 30 things a year, and I just get to see a lot of different really cool things. So I'm just going to use my climate work as an example of kind of how I do things, because I don't work in a lab and I don't do field work. So I'm pretty much programmatic, but I do have a technical background. So for example, I was able to take a high priority need, which is the call by the Secretary of Energy for sites to develop a vulnerability adaptation and resilience plan. And that was, and they wanted them done in less than a year. So it was a pretty tight turnaround. So I was able to take that need, learn the basic science behind it, and then apply the science to the greater need, and then support those individual sites with the development of those plans as the coordinator of that effort. And I've also been able to do some other really cool things through that same kind of framework where I collect data from other sites, other people, synthesize it, and then provide that information to higher level decision makers who make really important decisions for technical needs and regulatory and programmatic needs as well. Next slide, please. So my biggest recommendation is to try to secure a DOE internship if you're thinking about it. It's a really great, I loved doing it, it's really great. But I do have some recommendations on how to get the most out of it if you do decide to get one. So one thing I used to do a lot when there was downtime or it was close to a weekend or a holiday and I had nothing to do, I'd walk around the building, pop into people's offices if they didn't seem busy. And I would ask them, what do you do? Do you like your job? Do you need help with anything? So building those relationships are really important because people will remember you took initiative, you were friendly and things like that. Because if you have the internship, they know you can do the work. You're smart enough to do the work. So I thought it's really great to meet people. And again, as I said before, I was very shy and it took a lot of mental effort to go and do that. But I knew I needed to meet people. It's also really important, I think, to have a higher level understanding of DOE. We need to be able to see the bigger picture. I think I spent the first week or so reading up about the Manhattan Project and Cold War. So then you can see that there's many different jobs that you can do in the DOE complex. And then it will help you at any job you get at any site or lab or headquarters. And then it sounds really cliche, but I think it's really important to do your best because people will notice and then they'll give you a good recommendation. And then that's how I got my internship or my job. So meeting people and doing your best is really important. And then if you have time, I recommend taking any project that people ask you to do. People won't give you a project or a task if they don't think you can do it. And even if you don't think you'll like it, you might. So it's really great to get a full experience if you're going to be there. And then those were just some of the things that I did to get the most out of my internship experience. And it worked out really well for me. And it was absolutely the driving force behind me getting a job that I love very much now. And I've been successful at my job through those tools that I got during my internship. That's it. Thank you.
Great. Thank you, Emily. So, thanks to all the speakers. I appreciate that. And hopefully that gives folks here kind of a sense of what the national labs do, the kind of work that goes on, what internships are like, and how the kind of things you do as an internship, and maybe a pathway from going, even from high school to a career. So hopefully you found that useful. So I'm going to turn now to talk about some of the program-based internship opportunities. And I'll note that there are actually other postings. So if you go to any national lab and look at their career postings, there's probably some additional postings for things like research associates or other interns that are not part of a program. So do look for those as well. But I'll start out talking about some of the key programs here. At PNNL, we have 2 high school internship programs. The Student Research Apprenticeship Program and the Young Women in Science, SRAP and YOS. So these are for high school students. It's not constrained to students here in the Tri-Cities. We get applicants from all across the nation. There's certain eligibility requirements in terms of work-based learning. Because high school students were dealing with minors in some cases, you have to be a certain age, and if you're less than 18, you can't work in a laboratory. A grade point average, those sort of requirements, right? And typically for most all these programs, they'll have like a 10-week summer intern program. The high school programs actually have a 36-week academic year program as well. And Emily Dykes is our program manager at PNNL for this programs. And she's putting on a virtual career expo on the 1st and 2nd of February. And if you take a screenshot, there's the QR code for doing the registration. The next two programs I'll talk about are SULI and CCI. So these are for undergraduate students. So these are DOE programs. SULI is for undergraduates at universities. CCI is for community college students. But otherwise, they're pretty much the same kind of program. Again, 10 weeks in the summer. These programs actually offer 16-week internships in the fall or spring. And then CCI has some flexibility with that. So similar to other internships, you'll be assigned to a mentor, do a research project related to whatever the mentor's work is. And for these programs, you'll put together not only a presentation of your work that you did, but you'll also write a report. So that's we had some of the interns talking about communication skills and the importance of learning about technical writing. So you get an opportunity to do that. And these are all paid internships. You've got some information here on the pay and benefits for these. And the deadline for next summer is coming up pretty soon, January 10th at 5 p.m. Eastern. So if you're interested in that, Nicole Bentley and Nancy Rowe are the program managers at PNNL, and I'll have some more links here for other contacts as well in a second. The MSIP program, John talked about this up front, gave kind of that programmatic view, and again, kind of tried to impart the importance of interns and this program to DOE EM. So this program there's positions for undergraduate students and master's and PhD interns, as well as postdoctorate students. Again, this is the summer program is a 10-week internship, same sort of thing. You're working with a mentor on the research. But as with all these programs, we try to include other things as well. So laboratory and site tours, there's professional development seminars, workshops. Every national lab, they're going to have lectures and seminars going on all the time that you can take advantage of. And then there's social offsite activities for interns as well. So the MSIP interns for PNNL, internships for PNNL are going to be posted here in December, and they close at the end of February. So those will be found on the PNNL careers page. And then Savannah River has another link that I'll provide here in a minute to access those at other national labs. Again, these are compensated with a stipend. There's eligibility criteria that go with these. Really, we're looking for STEM students. We're focused today on environmental management, and that's the MSIP EM program is focused on that as well. Some of the other programs are a little broader. The high school and SULI programs expand beyond environmental science. So here's a good page to take a screenshot of. So this is some resource links. So the RemPlex web pages, we have a learn and study page, so you can get some information there. PNNL has a bunch of different pages here. There's a main page that talks about STEM internships, and then pages for each of the different programs. And then I've noted the careers.pnnl.gov page here. The SULI and CCI programs are run through the Office of Science's Workforce Development for Teachers and Scientists program. And so these are the main links for those programs where you would apply. And then the MSIP program is run through Savannah River National Laboratory. They're the lead lab for that program. And so they have a web page here that talks about the internships and how to apply for those. There are some other internship programs as well. WDTS also has a graduate student program. So that one has a deadline in May, and there's the link for their web page. There's a similar program to MSIP called Minority Educational Institute Student Partnership Program. This is run through the Oak Ridge Institute for Science and Education. And this is for internships at a variety of DOE offices and laboratories. And they have a deadline in January, end of January, for a summer internship. Emily was part of the DOE Scholars Program, also run through ORISE. So that is for undergraduate and graduate internships, again, at DOE offices, field sites, and they have close to the end of January deadline, the 22nd for summer 23. Then a third-party group that provides internships is the GEM Fellowship, and we've had GEM students, interns here at PNNL, and so there's the website for them. And they're doing fellowships for master's and PhD students in computer science and engineering. And then I put the link for ORISE at the bottom. They have several programs, so that's another good resource to go check out internships. So what do you do now? You've heard about what national labs do. You've heard from interns and staff. What do you do? Well, start early, don't procrastinate. You'll see the SULI deadline was at 5 p.m. Eastern on the January 10th, right? So don't wait until the 10th to get started. Start early, because you're going to need to put together some information, and you want to prepare yourself for applying to these internships. So make use of these links that I just provided. Make sure you review the eligibility and minimum requirements. A lot of times you fill out applications and there'll be some sort of automated screening that if you don't meet the minimum requirements, your application will get tossed out, right? So make sure you review those and you meet those requirements. Pay attention to those deadlines. Typically, the things you're going to need are some kind of essays or personal statements. The SULI and CCI applications have 3 or 4 different essays that describe, what are you interested in? What kind of experience do you have? What do you want to do with your future? Right. So you want to be thinking about these things and be prepared to write some essays and statements about those to help people look at your application and assess, what you're interested in, and if you're a good fit for the kind of work that they have. You generally need a cover letter, resume, transcripts. Some of these programs will ask for references, and I think the SULI and CCI programs actually have you have your references submit information about you. So make sure you have some of those rounded up, that you worked with people who know you and your skills and can provide a good reference. And whether that's a teacher or somebody in terms of a job, right? I would say you should also know something about where you're applying. What does the laboratory do that you're applying to? And I'll give SULI as an example, where you pick 2 labs of interest, and you want to pick ones that make sense, right? So if you're interested in biology and you choose Nettle, well, Nettle does energy research. So you want to pick the right lab that does the right kind of work, which goes back to some of the slides I showed earlier and the sort of scope of different activities that different labs do. So what can you do to prepare? I say look for opportunities to practice communication, both written and verbal. These are STEM internships, but a lot of what we do is actually communicating. We're writing reports, we're doing presentations, we're reporting back to folks like John at headquarters. What are we doing? How are we trying to solve problems? So the communication is really important. So make sure you take some opportunities to practice that. Take some STEM courses that align with your interests and give you some useful skills. And this could be, formal courses, but it can also be things like YouTube or LinkedIn Learning or Coursera, whatever, that give you skills that are going to be helpful. And develop those skills that you can talk about in your application. Things like lab work, if it's high school and you're doing biology lab or something, right? You can talk about that. Or if you have other lab experience at the university, maybe you have some computer skills, so some programming, scripting, things like Python or JavaScript or SQL databases, or data analysis and the kinds of software that you might use, right? So develop those skills, make sure you put those up front so mentors and reviewers can look at your application and see that information. And spend some time considering what are your interests and aspirations. Where do I want to go with a career? What interests me? And you don't necessarily have to have, that. I mean, you've heard several of the interns here talk about, well, I didn't really know about environmental science till I got into this, right? So you don't necessarily have to have that mapped out, but you want to think a little bit about what am I interested in, what potentially might interest me, because that's things that mentors are going to look at to help understand, is this a good fit? Are you the right kind of student for the kind of work that we have? And then lastly, I say, get involved, demonstrate that you're involved. You've got a job, you're involved in clubs, you're involved in the community. I think that's always going to be a positive point that you can talk about. It gives you some experiences and situations you can talk about. So those are good. And really, you kind of looking ahead to where you want to go, and start now to build these skills and interests and prepare yourself to apply to an internship. So what are mentors looking for? It really kind of depends on the level, right? A high school student is very different from a graduate student. If you're in high school, we're not expecting you have a huge amount of research experience. Whereas a graduate student, we might be looking for that student that has a particular background or interests to fill needs as we're solving our challenges at the national labs. So it just depends. But really, what is the student interested in? That's going to be a key piece. You don't necessarily have to have all the skills right now, but have to show some interest and motivation. And we're trying to find the right fit. Do you fit with the work in terms of interests and potentially skills? And so they'll look at student skills. What are those? What coursework have you done? That'll be kind of a foundation to build on. It's not going to be a primary factor if you haven't taken a particular class, but that tells us something about what you know, where you're at, and we can go from there, and we can supplement that in an internship and teach you things. The nature of your experience is going to be helpful as well. We'll look at that. What kinds of job experience do you have? Even if it's experience in clubs or working in the community, volunteering, those are going to tell us a little bit about your characteristics in terms of leadership or teamwork, reliability, communication, all those sort of things. So we're going to look for that kind of information in your application. I'd say grades, they're an indicator. They're not a primary factor, right? So if you don't have the straight A's, that's not going to disqualify you, right? Because we're really more interested in who you are, what you're interested in, what your skills are, some of these other things that I listed first. And I circled down here communication and problem solving. Again, those are really characteristics that are, if you can solve problems and communicate, those are the things we're looking for, because that's what we do. We solve problems and we communicate. And here's sort of a word cloud. We're looking for students who are passionate, or maybe you're still finding your passion, but all these things here: you're curious, you're adventurous, you're communicative, adaptable, always learning, right? So these are the kinds of things we're looking for to bring in interns, help learn, solve problems, gain experience, move our projects forward, right? And a couple more things here to consider. And I say, you've seen some information about getting paid, and I say, that's nice. But I think, as you've heard from the other interns and speakers here, really the big prize from this internship is the experience and the mentoring. You're making connections, you're getting experience, you're taking advantage of the networking, the staff at the national labs and other DOE offices. They're going to be supportive of interns and happy to talk to you about what they're doing, and help you and help answer questions that you have, right? And then there's other things like seminars and other opportunities during an internship to help build skills, right? So currently, opportunities at the different labs and sites can be remote or on-site. Just kind of depends on the nature of the work. If you're doing chemistry work in a laboratory, you're going to be on site, right? If you're doing computer work, it might be remote. It might just kind of depend on your situation, interest, the nature of the work. Both ways can be great experiences. We've had a number of students here that had remote internships and some that did on-site internships, and they're both great. So again, be sure to identify your interests when you're doing your application. And that's really going to help the program coordinators for these different programs place your application with the right potential mentors. And so if you're interested in environmental work and you're looking at PNNL, I would mention RemPlex, for example. So a few takeaways from this, National Labs, we're doing the critical research to solve the nation's most challenging problems. And we're working in basic science, energy, environment, and national security. Environmental cleanup, it's really a multidisciplinary effort, team effort. So we're not just environmental scientists, we're a whole bunch of different kinds of disciplines coming together to solve problems. And there's multiple programs that I've talked about: SULI, CCI, MSIP, SRAP, and Young Women in Science for internships at all levels from high school through undergraduate and graduate levels. So again, do your homework, apply early, demonstrate your good communication skills, writing and attention to detail, and highlight your interests and skills and characteristics, your leadership, your teamwork, etc. And with that, I'll say thank you for watching, and we'll be open to questions.
Thank you so much, Chris, and to everyone who presented. I think it was great to hear the stories, and I hope people find this information useful. I'm going to mention that we've put an awful lot of links in the chat, but they will all be available in the file that we post that has the slides, and they'll be active links, correct, Chris?
That's
so
correct.
People can just open the PDF and they can get to each of the links we've shared. And I want to encourage people, I'm going to share a screen quickly. I want to encourage people to sign up for, I can't share, Chris, because you're still sharing, to sign up for our newsletter in RemPlex, and you can go to the RemPlex website, and that's we've provided that link multiple times in the chat. And am I showing this screen? This is the slide showing the summit. I'm working on just my little laptop. So
yes.
So this is an advertisement for the summit that we're hosting next November. There will be a student rate. We'll be issuing a call for abstracts in about April, and there's information on the RemPlex website about the summit itself. We put that link in the chat as well. So just wanted to share that briefly. Do we have any? I think we might have some questions in the chat. Is that right? Maybe not. Nope. Just
no,
some,
Karen. Yeah, it was just asking about the links and that.
Yeah.
All right. Any parting words from any of our speakers? I really do appreciate what everybody shared today. Okay, we will be posting these slides. We'll be posting a recording of this seminar. Please share it with other people that you think might be interested in these opportunities. And thank you very much for joining us today. We hope we see you again.
Yes.
Bye-bye.